Hi, Keith McGuinness here. In this short video tutorial, I'm going to look at doing some analysis of variance type analyses with the package PAST, Paleontological Statistics. Before I do that, I'm going to look at the data files in Excel and do a little work in Excel to start with. So first, looking at the map, you can see that I've got samples at impact locations and control locations. So my design here has two factors, impact versus control, and location or site 1 versus location or site 2. And we could alternatively think of this as the northern and the southern locations. Now, when I talk about this as site 1 and site 2, I'm just using that to group these together and these together. In other words, to match the impact and its control. In terms of sampling, they are 4 separate sites. And that's how it shows up if I run to the costing page. I've set up 4 sites with 12 samples. And because I've got complete biological and chemical processing, or chemical processing and full biological, total cost comes out at around 50,000. That doesn't matter for me because I'm just doing a demonstration here. Let's look at the data. So here are the data, and it looks pretty much the same as sets of data you'll have. We've got the counts of individuals for the different worms, mollusks and crustaceans. The chemical data in here, the sample locations there. And then I've added some information into 4 columns in here. Now, when you get the results from me, you usually have 2 blank columns headed label 1 and label 2, where you can insert this type of information. Now, I've added a couple of extra blanks in here. So you can see I've got over here status, impact versus control, and I've also got it over here status in numerical terms. And that's because for a number of analyses, PAST will want information, coding information, in numbers rather than letters. So I've coded by status, impact versus control, and site north versus south, or 1 versus 2. The other thing I've done here is create a code column, which is labeling the samples by the status and site. So I1, impact 1, I2, impact 2, and so on. Right, let's copy that. Head on over to past. I've got edit labels checked and edit mode on, so I can simply paste the data in there, then turn both of those off so I don't make any mistakes. Again, my first row has been used to label the column, and my first column has been used to label the rows. And that is particularly helpful when it comes to drawing graphs. One thing I may not have demonstrated in the other videos is that we can easily rearrange columns and rows in PAST by dragging them. And that's handy if you want to get variables next to each other. So if I want to get hydrocarbons next to depth, so I can draw, for instance, a XY graph, I can just drag that column. Now I'm going to move it back over there because that's where I want it to be later. I can also change rows, so I can move that one and that one and that one up, and now I've got all the impact together and all the control together. Another thing that it's handy to do for graphs and for some analyses is to give the rows colors and symbols. So by clicking on there, I've tagged all of the impact samples with the color red and the cross symbol or plus sign. And I can do the same for the controls, which I'll tag with a blue square. Now the reason for doing that is that then those colors and symbols will show up in any graphs that I draw, and that will make them easier to interpret. Okay, you can do 1 and 2 factor analysis of variance using the package Excel Stats, and that is what I recommend. It's easier to do the analysis there than here in PAST. We can, however, do 1 and 2 factor analysis of variance in this package. Now, the 1 factor analysis of variance is a bit odd, and it's one of the things that you discover about working with PAST is sometimes they're a little bit inconsistent. So if I go stats, OneWay, it says no area because I haven't selected any data. Nearly always need to do that with Excel, with PAST. So let's select a column there for mollusk 1. I want to compare impact versus control. Stat OneWay, need at least 2 columns. Okay, well, what's going to happen if I take all the 3 mollusks? OneWay again. Okay, now it's done an analysis. And it's a standard 1 factor analysis of variance up here, sum of squares, degrees of freedom, mean square, and F. The p-value here is 0.107743. The e minus 11 means we've got to move the decimal place 11 places to the left, which will give us 10 zeros in front of it. So the analysis is significant. P is much less than 0.05. And what's that telling us? Well, what it's doing is comparing the abundance, the average abundance of the 3 mollusk species. So mollusk 1 versus 2 versus 3. In most cases, that kind of comparison here for the global oil studies not going to be particularly meaningful. We expect the species to be in different abundances. So to get a control versus impact comparison using PAST, I'm going to have to really move the data around quite a lot in order to get it into different columns. That's why I say do these kinds of analyses in Excel stats, because you have to do relatively minor manipulations of the data file, usually nothing much at all. What's going on down here? Let's have a look at this because we'll see these turn up a little bit later. What it's doing here is individual pairwise comparisons using Tukey's pairwise comparison procedure. And you can find that listed in the SBI 209 statistical manual if you want to look up a little bit more detail about it. The bottom values in here are the test value, and the values over here are the p-value. So all of these are less than 0.05. So all 3 comparisons are significant, which means that mollusk 1 is different from mollusk 2 in its average abundance, and from mollusk 3. And mollusks 2 and 3 differ also in average abundance. As I've said, that's not particularly useful, but we'll see another one of these a little bit later on. So let's close that. The 2 factor analysis of variance in here is rather more useful, and I'll just go and do it straight away. Here we select 3 columns. The last one is the variable that we are testing a hypothesis about, and the first 2 are factors 1 and 2, or factors A and B. So the setup here is pretty much the same as it is in Excel stats. TwoWay ANOVA. Here's our results table, standard 2 factor analysis of variance. All of these p-values are less than 0.054, so there's a significant difference between impact and control, site 1 and site 2, and an interaction. And the interaction is saying that the change from impact to control is not the same at sites 1 and 2. And if you go here and just look at the values, you can see at the control locations, hydrocarbon levels are small, around about 0.2, 0.3, and there's not obviously a difference between the 2 sites. When we get to the impact, however, there is. Here, site 2 has hydrocarbon levels about 20 to 30. Site 1 has hydrocarbon levels of about 35 to 55. So there's a lot more hydrocarbon pollution around site 1 than site 2. But overall, there is still a difference between impact and control. I'll probably be drawing a graph to illustrate that, and again, that is easier to do in Excel stats. So run Excel stats for 1 and 2 factor analysis of variance. Okay, now If we're not going to do one and two factor analysis of variance in PAST, why am I doing this video tutorial? And the answer is multivariate analysis of variance, or multivariate kinds of analyses of variance. Now, towards the end of topic 6, we look at one attempt or one approach for doing an analysis of variance kind of statistical test for multivariate data, and that's OneWay ANOSIM. Now, we can do the OneWay ANOSIM here in PAST, but there's also options for TwoWay and something called One and TwoWay NP Manova. Now, that is actually more commonly referred to as PERMANOVA, and I'll talk about that in a moment. Again, with one and TwoWay ANOSIM, PAST is a little inconsistent, but let's give it a go. So what I'm going to do now is I'm going to select all of the columns, all of the data for the species. So I've selected all the biological data and stats, multivariate, OneWay ANOSIM. Now, OneWay ANOSIM actually uses our color codings up here to for the groups. So it's doing a comparison between impact and control. And you can see that from the fact here that it's actually using the labels from the first row of each group, impact 1 and control 1. So the test statistic for the ANOSIM is something called R. I'm not going to go into detail about how that derives. We do have to pick a distance measure. It's defaulted to Bray-Curtis, which is appropriate. P-value is less than 0.05, so there's a significant difference between control and impact in the community composition. And that's based on looking at all of the species. And the little table down here is the same kind of table we saw before doing tests between the different groups. In this case, there's just two groups, so it's just comparing impact and control. That value is less than 0.05, so it's really repeating the same tests up there. And this plot here is a plot of distances between the groups, so comparing group 1 and group 2. I won't go into that any further here. So that's OneWay ANOSIM, and you can look a little bit more, read a little bit more information about that in the study guide and the readings. We've also got TwoWay ANOSIM, and I'm not even going to try, let me think, can I run that here? Didn't try running this before. Okay, I've run it. It uses the same setup as the two-factor analysis of variance. I just had to move the columns over so that they were the first two columns in the complete set of data. Up here, doing a test for the status factor, impact versus control, that's significant, and the site factor, impact versus site 1 versus 2, that's significant. Again, we're using the Bray-Curtis similarity measure as we do when we're doing MDS for the biological data. Now, what's missing here, and what is the major limitation of the TwoWay ANOSIM and the ANOSIM procedure in general, is any interactive effect. So the ANOSIM procedure can't test for an interaction, and if there is an interaction and we're missing it, then we're missing important information. Up here, note that the procedure is doing nearly 10,000 permutations. I'll talk about that again in a moment. So, ANOSIM is now falling out of favour in preference to PERMANOVA, or what PAST calls NP Manova, which is non-parametric permutation Manova or something. Because we have a two-way design here, we should do the two-way NP Manova, and here it is. So you can see why it's referred to as an ANOVA, because it gives us results which are very similar in format to an analysis of variance, ordinary two-factor. Status, site, and their interaction, sum of squares, degrees of freedom, mean square F, and p-value. Now, we've also got this permutation thing up here. What you've got to remember about ANOSIM and PERMANOVA is that the p-values are generated by permutating the data. What does that mean? Basically, it means that the F values are calculated from the original data, and then the significance of those is determined by permutating or randomizing the data, mixing the labels up among the groups. And that's done a large number of times. In the case of this procedure, 10,000. And by comparing the value we calculate for the randomized values, we can get an idea of whether it is unusual or not. So the calculated F value for status is 23. When that data is randomized, that turns out to be highly unusual. The p-value is 0.0001, much less than 0.05. For site and the interactive effect, those p-values are around about 0.05. In the case of site, it's a little bit above that. So the interactive effect there is marginally above 0.05, so not significant, and the side effect is not significant. So the main thing that's coming out here is a difference between impact and control, though we might actually suspect that there might be an interactive effect. If I want to do this again, switch distance measures, and it redoes them. So you can see if I switch out, switch back to the Bray Curtis, these values change a little bit, but not greatly. So these are both sitting just above 0.05. So the main effect here in terms of community composition is difference between impact and control. There's maybe some slight additional effects due to the fact that there's a little bit more pollution at one site than at the other. Now, the advantage of this procedure here is that it gives us analysis of variance type results, which can be interpreted in the same way, but it doesn't have any of the restrictive assumptions because it's based on simply using randomized data to determine the significance. And because it's an analysis of variance type framework, we can use the same kinds of models that we use with analysis of variance. So the two-factor here for the entire biological community looks the same in terms of its overall structure as the ordinary two-factor analysis of variance for just testing hypotheses about hydrocarbon. If you had a one-way design, say we just wanted to compare two statuses, select multivariate OneWay NP Manova, and similar sort of display here. There's our F value. P-value is again much less than 0.05, so the significant difference, and we're comparing impact versus control. And I suspect that I've just done that wrong. So I suspect we just So for this, it's taking the groups from our color coding as it was for the OneWay ANOSIM. Okay, what I've tried to do there is illustrate the procedures for doing ordinary analysis of variance and the multivariate versions within PAST. For the ordinary analyses of variance, you're better off using another package because it's going to be more flexible and give you more in terms of results, graphs, and so on. For the PERMANOVA type of analysis, PAST works very nicely, and there are relatively few packages around. In fact, I know of no other free packages around which can do the PERMANOVA as easily as you can do it here. And it's worth exploring that now that we've got this tool in your own analyses.